The malware's messenger, Telegram API abuse as C2. Since 2016, precisely, yeah, before that it could be, but since 2016, we have been observing a lot of activity that was basically happening onto the malware side, where Telegram's bot API was used for command and control implementation. So let's go to the next slide. Who am I? I work as a principal engineer with GoDaddy. That's my day job. But apart from that, I love fuzzing C and C++ code. I play CTF and what else? Yeah, I basically try hunt malware, C2s, bots, just as a pastime. Yeah, that also is a part of my work, but that's sort of an unwinding exercise I keep doing. Yes, big fan of Unix kernels, toolchains, open source software, and yeah, still a CTF player. I am reachable here. I'll share this slide at the end as well, but just in case somebody wants to have it handy right now. So why exactly did we focus on Telegram? So from a legit use purpose, we can say, Telegram has been like yet another messenger into the arsenal. Everybody uses it. So does threat actors. At the beginning, when Telegram was introduced, it was relatively less secure compared to what it is today. It was very, very easy to set up Telegram onto a virtualized environment as a desktop app, which otherwise was a challenge for a WhatsApp or Signal per se. So that was the initial thought process, I believe, threat actor nurtured. And then we have seen a lot of activity where Telegram was used to basically, discuss a lot of interesting things amongst threat actors, amongst researchers as well. As a matter of fact, there are a lot of initial access broker-based groups. They actually use restricted Telegram channels to discuss a lot of things and to even recruit newcomers into their ransomware gang as well. Apart from that, there are some Telegram channels and groups where we have seen a lot of actors boasting and advertising their threat activity or threat activity plan well beforehand. A lot of such information was found during the friction moments between Arab and Jew-based conflicts. To be precise, every year, right from the month of March to the month of July, these messages are quite frequently found, where threat actors advertise saying, okay, we are targeting so-and-so IP address, and with this particular GBPS bandwidth or something like that, we are targeting this particular domain, we want to DDoS this domain at this particular time, GMT something. So this was also, this is still persistent and consistent onto a lot of Telegram channels as well. This was the background for this whole research to begin with. And essentially, onto the malware side of the threats, a lot of malware have been using Telegram, specifically bot API, for command and control mechanism into their creation, we can say. Having analyzed some of these activities in past, I thought it is time to basically share the learning with the wider audience, and hence I'm here. Idhar jaun? Okay. You want me to stay here or there? Okay, fine, no problem. Yeah, so no more BS sort of thing. Let's go directly to the technical part of the story. So like every API, Telegram also shares a lot of endpoints which can be used by legit users or abusers for interesting behavior. So this is a legit use. Whatever that you see in red font or in the font in the red color, consider that as something which can also be abused. So I basically listed a couple of what we can say functionalities of API, where messaging and broadcast using sendMessage endpoint or edit message endpoint. More than 4096 characters can be involved into this whole thing. File handling, interesting part. We will come to know in a couple of minutes why this is interesting. So getFile is the API used there. And third is getUpdates. So this API, this endpoint is usually used to poll a specific host for the information delta that the actor is trying to extract or exfiltrate. Now the abuse part, same thing, wearing a different wheel. getUpdates, like beaconing and tasking. Beaconing and tasking, as I have already explained, this is like more for fetching the delta from the updates. Exfiltration, sendDocument, send file, send photo, send video. These all endpoints, they basically help again exfiltrating data. And now many of you might have figured out like where am I going to. Keylogging, other possibilities as well. So any guesses so far, like where do we usually observe these kind of things in the latest type of threats? Any guess? Okay, info stealers, right? Here it is. So as of now, majority of the operations or threat activities that involve C2 have significant share towards info stealers. I'm not attributing a specific family of info stealer here. Reason being, this is sort of really a volatile implementation. Anybody can quickly, write a small script or program to have this particular Telegram bot integrated into their functionality. So basics of C2 ops from the Telegram perspective. So an actor infects a machine, okay, using any mean. It could be any mean. We are not considering what type of mean it's going to be. And the infection vector, the binary or the file using which the infection was triggered is usually packaged with the Telegram API URL or tokens or IDs or details related to that. Okay. Again, I'm trying to keep this conversation as less jargon enabled as possible, so that everybody would be able to grab the at least basics of this whole thing. So get me endpoint is something which is sort of an introductory endpoint or the introductory communication initiated from infected machine, from the victim machine to the adversary machine. And then the next thing is getUpdates thing. It's basically to poll and see if there is something interesting lying onto the box. And if so, victim machine will trigger the post message with the adversary machine will trigger the victim machine will trigger the post message with send message thing. Exfiltration part. So this is the interesting part. So usually whenever we are dealing with info stealers, actors are targeting for some DB dumps, some heavy files, which cannot be basically fetched into one tiny packet, and there is where this multi-part post implementation comes in picture. So this get request is usually triggered by the adversary saying, okay, I want a specific file. So how does adversary know this particular file is something, the file name is something that I need? Is basically been done by the post request which was triggered by the adversary onto the victim side saying send document. So this basically sends back a JSON response where the actual absolute path of the file is sent back to the adversary. Interestingly, this communication is not visible to the full channel. This communication actually happens between the victim and the adversary's accounts onto the Telegram channel. So apart from these two entities, nobody can see this thing. So this is the interesting part. I purposely did not mention delete message option here as well, but many a times we have also observed that after receiving the file onto the adversary's end, adversary triggers delete message endpoint call as well, so as to remove all the traces, at least from the channel standpoint. And once that particular JSON response is received, where the actual absolute path of the file is present, all the adversary need to do is like get, basically have this particular request triggered, where you can actually embed an absolute path and can fetch that whole file. So this is the normal exfiltration scenario. There could be more, but this is the very, very rudimentary exfiltration scenario that could be discussed here. In the recent tasking that I was involved in, there was also a scenario where we have seen a lot of wallets and wallet addresses, wallet databases being exfiltrated using the same mechanism. That activity was targeted for Mac OS environments specifically. But yeah, these are the details as of now I can share with you related to the latest activity. Yeah, so that was the technical part. I understand I purposely kept it shallow so that everybody would be able to have some takeaway from the talk. This was something where adversaries play a lot of interesting things onto victims' box. What can be done to detect? Now, this is something where defenders comes in picture. I hope majority of us are. So first thing, yeah. So I basically categorized detection recommendations on two sides. One is host side, another is a network side. So this particular library called tdlib is sort of a giveaway mechanism by Telegram, using which a developer or a firm can build its own Telegram-like application and can use it for their own purposes. So far, we have not seen any threat activity involving tdlib, but that doesn't deny the presence of that particular functionality onto the threat actor's arsenal side. Having said that, what can actually be used on rudimentary grounds, what we can detect is tdjson.dll for the Windows-based host and libtdjson.so. We can do a lot of fine-grained detection here as well. Those who are interested, we can discuss this thing offline, where we can get into the details of the actual workflow, actual APIs involved, basic blocks involved, and whatnot. And accordingly, we can create or rather craft or curate more accurate detection and can keep enhancing that part. Other part of the detection could be the hard-coded tokens or chat IDs. So let me quickly take you back to this slide, any of that. You see this bot token mentioned? So usually this bot token is nothing but the keyword bot appended with around 46 characters, alphanumeric characters. So that could be another unique scenario that could be covered into the detection part. Same thing applies to chat ID as well. So chat_ID, all capitalized, is the keyword that you would find in all communications which are involving Telegram bot API. Yeah, I think we have covered that. As well as I have mentioned about the initial infection part where the victim is infected with a binary, many a times we have observed that these bot tokens and chat IDs as well hard-coded into the binaries. So that could be another interesting scenario that could be covered from the host-based detection side. Opportunities for network-based detections. I know the previous host-based detection can actually be extended to way beyond what we have discussed. I purposely kept it brief just to begin with the detection. Okay. Onto the network-based detection, the first thing that we can detect is any HTTP request or any network request that is resolving to api.telegram.org. The second thing that we can detect is presence of t.me domain. Like that, there are 6 more domains which Telegram allows its apps to communicate with onto the Telegram's infrastructure itself. The sequence of API endpoints which are usually found into the traffic is something like this: sendMessage, getUpdates, then the command. So this command part is the custom thing. This command actually involves the custom implementation of the adversary's motive, like whatever the adversary wants to trigger onto the victim's box. It could be like that. It could be like a simple shell command, could be something more relevant or interesting, could be anything, right? So is the reason I purposely kept it vague. And then sendDocument. Once these all details have been acquired, send it back to the adversary. So this is the usual sequence that was observed. So onto the network side, if we can find these endpoint calls from the api.telegram.org, this could be something worth alerting for. Definitely it would require more investigation depending upon the organization's motive, like why the Telegram bot has been used in first place. Another interesting thing is JA3 signatures. So since Telegram is like presumably end-to-end encrypted for the communication part, they definitely have a lot of their own implementation of TLS, which can actually be fingerprinted using JA3 signatures. So we can access list those communications or those TLS JA3 signatures which are legitimate or known to the organization or enterprise from the communication perspective. Rest everything could be dropped. Yeah, alert, yeah. So getUpdates, as we have discussed right from the beginning, is something where we try to fetch the delta from the previously exfiltrated data and then present state of data which was not exfiltrated. So these getUpdates have been seen frequently getting triggered onto the victim's machine. And usually, depending upon the bandwidth, around 30 milliseconds time window was used per getUpdates. So this could be another unique scenario which can be used to trigger an alert. Like say, for example, there are dozens of getUpdates getting triggered within an hour, and each of them is having more than 30 milliseconds of time window assigned to it. So again, the time window that I'm speaking about is available into the API documentation itself, and that is visible into your communication directly. So nothing secret there. The last one onto the network side is like, in one such scenario, I have observed that Telegram API was actually being resolved to a shortened URL. So essentially, whatever that was being triggered from the victim machine was not at all suspicious, but later when we investigated, it was getting resolved to a api.telegram.org. So obviously it was a proper exfiltration scenario, but yes, that is one remote situation. Haven't seen that in last like 4 years or so, but yes, it is still there. So, too long, didn't read. First question that we should ask, those who are decision makers, those who are advisors, those who are CTI members or defenders, do we really need any such messaging apps presence onto enterprise machines? Because they are the playgrounds, actually the playgrounds for threat actors to leverage your enterprise's capability for their benefits. So this question has to be asked and has to be put crisp and clearly into the threat register. Do we really need any such messaging apps in our enterprise environment, on our enterprise boxes? If you ask me, the answer should be no. But yeah, depending on the different business logics, there could be different answers. But accordingly, the presence has to be tracked and has to be checked and has to be alerted if going out of control anytime. Second thing, if yes, why? This should have again a very, very clear answer documented. So like tomorrow, if something happens, we have a proof of the decision and the reasoning for that decision already documented. So whatever the answer that we would be giving maybe to law enforcement agencies or something like that in case of an incident, it will be supported with the relevant documentation which was built well ahead of time. Yeah, and yes, keep monitoring is the last thing. Just mimifying the things, don't worry. This slide is actually the crux of everything I have discussed. From defender standpoint, threat actor needs one opportunity, one access, or rather one attack to be successful. On the other hand, defender needs to be successful every time. One failure and all the other attacks which have been thwarted in past will go for a toss. So just be more and more careful as much as possible. That's most of it from my side. If there are any questions, I'll be happy to answer.
Currently, we used to see a lot of Telegram-based detections, like sometimes people are using Telegram for their own purpose, and sometimes we used to see that some of the channel names, malware contains channel names are there. So we are trying to figure it out, the source, access source, how is there any method to reverse engineer that so we can. Oh, okay. Am I audible now? Okay. So we are seeing a lot of kind of detections based on telegrams, and we are getting a lot of threat intel based on telegrams. So we are trying to reverse a little bit more to figure out if there is any proper channels or malware based mainly because of malwares. So people are using Telegram as a source to download or inject the malwares inside the machine. So any specific detection methods or any way to reverse, and how can we improve our detections in that? Because currently we are using the API and all other things as a detection method, but we need to improve a little bit more.
Okay, is that the question? Or you have more to it?
First part of the question.
Okay. As I have already explained, document your purpose, like why the user should have any such messaging app present onto the box. Okay. Make it a policy. Yeah. So if they don't comply, things would be already highlighted. And for those highlighted users, let there be a proper approval process running across the chain of command. So right from the manager to the VP or CISO, whosoever it is. So like whosoever is using any such apps for non-business purposes onto their business assets, they will be having a separate monitoring list in place. Okay? From detection standpoint, having this basic domain-based detections, DLL and source object-based detections and other network that I have already explained is as of now sufficient. Reason being, if we know somebody is using this, there is no point going, mincing that communication further, because once the policy is made, everybody has to comply.
Yeah.
I understand the answer is little bit less technical. Reason being, these are the controls which or these are the policies which has to be in place. Because once these policies are there, then the technical people will have more say or a stronger say to table, right? And that's how it should actually be planned. We can discuss this thing in more detail offline, because there could be some scenarios which you probably don't want to discuss in public. So yeah, we can take that offline if that works for you.
That definitely helps. So we
Thank
can
you.
Discuss later.
Are we done? Because there is hardly one slide. That's it. Okay, no problem. Yeah, so I think we can not take any more questions here. So I'll quickly share this slide. If you want to reach out to me, have questions, want help, or what we can say, suggestions on to hunting different interesting artifacts, I am happy to answer.
Please give a round of applause for
So yeah,
Mr.
that's most of it. Those who come from old school C, C++ background, they might be knowing the significance of exit 0. Thank you all for being a nice audience. It was really nice talking to you. Have a great day.